This video is about graphing the cotangent function. So just some bullet points to remind you here. The cotangent is the reciprocal of the tangent. So on the unit circle, while tangent is y over x, cotangent is x over y. And think about this. If they are reciprocals, then anywhere the tangent is equal to 0, the cotangent will have an asymptote, and vice versa. Where the cotangent is equal to 0, the tangent has an asymptote. The cotangent branches will all be decreasing, and the period is going to be the same as the tangent. It is pi units long. So we're going to graph the cotangent function by hand here, and I've already got a little unit circle drawn, everything we need, and I've got a little XY chart ready to go here for y equals cotangent x. So keep in mind, once again, we already know the period length of the cotangent parent function is pi units. So let's start plugging in some values here. So let's put in a 0. So if we go to 0, we go x over y. That's undefined. So there's going to be an asymptote at 0. Next, let's go to pi over 4. At pi over 4, x over y is going to be equal to 1. At pi over 2, we have 0 over 1. That is 0. At 3 pi over 4, 3 pi over 4 x over y, that's equal to negative 1. At pi, x over y, that is undefined. That will be another asymptote. And then 5 pi over 4, I'll squeeze one more on here, 5 pi over 4. Remember, quadrant 3, the tangent and the cotangent are positive in quadrant 3. That's equal to 1. So this goes from asymptote to asymptote. So that's going to give us one full period. So using my XY chart here, let's put some values on my x-axis. And I'm going to go in terms of pi over 4, so 0, 1/4, 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, 8 pi over 4, 9 pi over 4, and 10 pi over 4. So this is a good enough amount in the positive direction. Let's do some in the negative direction. And we are going to have asymptotes at 0 and pi. I will do that with a highlighter. Remember that asymptotes need to be dashed lines because they're not part of the graph, but they are guidelines telling us where to stop. And then another asymptote at pi. Remember, this is one full period right here. From asymptote to asymptote, one full period. So 1, 2, 3, 4, another asymptote at 2 pi, and another asymptote over here at negative pi. So if we start plotting these points based on our XY chart, over pi over 4, up 1. This will be 1, this will be 2. Over pi over 2, 0. Over 3 pi over 4, negative 1. So here is one branch of the cotangent graph. Same thing's going to happen when we get on the other side. At pi, it is an asymptote. At 5 pi over 4, it was equal to 1, which means there's a x-intercept at 3 pi over 2, and another point at 7 pi over 4, down 1. And another decreasing branch. Remember, all the branches of the cotangent parent function are decreasing branches. We'll draw on one more right here, and this is your cotangent parent function. So I've got a couple more that we will kind of speed through here now that we know what the cotangent parent function looks like. So our parent function has an asymptote at 0 in comparison to a y-intercept at 0 for the tangent. So now we're going to change it a little bit, it's going to have an A value of 1/2. So basically, all it's going to do to these values is squish them. Remember, our A gives us a vertical stretch, or in this case, a vertical compression. So this time we have an A value of 1/2. So 1/2, 1, 1 and 1/2, that is going to be plenty to get the job done right there. Whoop. That's 1. That will be 1 and 1/2. There we go. So I don't have my magic tape. This will be good enough. All right. So pi over 4, pi over 2, 3 pi over 4, and pi, negative pi over 4, negative pi over 2, negative 3 pi over 4, negative pi. So this is the cotangent. We know that we have no phase shift. We have no period change. So that means there's still going to be an asymptote at 0. And there's still going to be an asymptote at pi. Still going to be one at negative pi. But the only change here is that A is 1/2. So it's compressing. It's compressing each of the branches. We know the branches are still going to be decreasing. If that was a negative 1/2, then they would be increasing. But it's not. A is positive 1/2. These branches are going to decrease. So that means we're still going to have an intercept there. And this time it won't be as tall and skinny. It'll be a little fatter and flatter in the middle of those decreasing branches. And those branches are going to hug right up next to those asymptotes. Finally, switching it up a little bit, we've got an A value of positive 3. And I think I'm even going to make it negative 3 just to make it more exciting. So an A value of negative 3, which means instead of decreasing branches, our branches are going to be increasing because this is the cotangent. But we do have a B value here. And remember, a B value changes the period. So if we have a B value of 2, our period is going to be pi divided by 2. So we are squishing those branches. We're going to have a higher frequency because we are squishing that period in half. So if we're squishing the period in half with no phase shift, we're still going to have an asymptote at 0. But let's think about this. If we have 0 here, if we just go up by pi over 4, that is going to give us a very tiny space to draw in that branch. So instead of numbering by pi over 4, let's number by pi over 8. 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, 7/8, 8/8. Let's go in the negative direction. I'm numbering by 8s just to make this a little bit more precise. That's all that's happening here. So no phase shift. Still no phase shift. Still going to have an asymptote at 0. If there's no phase shift, there's going to be an asymptote at 0. We know the length of our period is pi over 2. So from 0 to pi over 2 is going to be 1 period, and from 0 to negative pi over 2 will be another period, and we can just go crazy and put another one right here. Our A value is -3. And when our A value is negative, it does create a reflection. In this case, the easiest way to think about it is instead of having decreasing branches when A is positive, we're going to have increasing branches when A is negative. And it is going to stretch it out vertically, or I should do it in that orientation. So we're going to have an intercept on the x-axis right in the middle, in between those two asymptotes. We want an increasing branch, so we're going to go back one increment, down 1, 2, 3, over 1, up 1, 2, 3. This is what one period, I missed the point, one period of our tangent function, y equals -3 cotangent of 2x. Do it again. Hit the points this time. There are 2 periods. Do it one more time. Remember, our intercept, our middle of our branch, is always going to be directly in the middle in between those two asymptotes. There we go. That is the cotangent.